Then Roman 4, we are asked the 95% confidence interval for the project's completion time. 95% confidence interval is Roman 4. 95% confidence interval. If I was to draw the normal distribution for this project, then this is how it will be. So we are asking that if this is our average, this is our average, or let me just have this way, this is our average is 85. Then we want 95%, so which this area is 95% confidence. So we want this x1 and x2 to represent our lower and upper limits. And of course, this being the mean, let's give it as the expected time. Then the standard error of time shall be, the standard error here will be taking the standard deviation of the project variance or standard deviation. Let me just put it as an S, we divide by root n. Meaning, if I take the standard deviation of this project, which is 42, but this is the variance, I need to take, you can see that where S is the standard deviation, is given as the square root of the 42.44, which is going to give us what? If I take the standard deviation, this is square root of this 42, this will give us 6.51. Now, this 6.51 days is going to be taken to be now our standard deviation. So we say that, therefore, standard error of the project time is given by 6.51 divided by the square root of n. N is the number of the critical activities. 1, 2, 3, 4, 5. There are 5 critical activities out of, I think, the 8. So this is 5. So to some extent now this will be 6.51, you divide by the square root of 5. This is giving us 2.91 days. So having said that, having known this is 2.91, now we can be able to determine, remember, this area that you are looking for, total of 95, is what we call symmetrical. Symmetrical means it's balanced. So this side and this side, this must be 47.5%, 47.5%. In actual sense, this is 0.475, 0.475. So we just need to read from the table what is the Z value, in the table, because we need this. We need that x1 should be the expected time. So, and then we add or we subtract the Z and the ST, while SX2 we need expected time, but now we are going to add Z, then you have the ST. So to get Z, so we can say that where Z 95%, this is, let me say 95% two-tail. Two-tail means the probability we are looking for here, probability, will be CL over 2, which you know is 0.475. Z table shall be, if we go to the table, and we do have a table here, this table of normal distribution, we have the probability, and the probability is 0.475. Likely enough, it is exactly provided under the 1.96. 1.96, inside there we have the 0.475. So 1.96 is our answer. 1.96. So with that now we can be able to determine the lower and upper limit. We can determine this way that x1 is going to be 85 days minus 1.96 multiplied by 2.91, while x2 is going to be 85. We add 1.96, 2.91, like that. So how much is this? So if we were to multiply or we were to determine it using the calculator, this is 85 minus 1.96 times 2.91. This is coming to 79. So let's say 79 days. While the other one is 85 plus 1.96 multiplied by 2.91. On average, this is coming to 91. This is 91 days on average. That tells you that the 95% confidence interval, it is between 79 to 91 days. So between 79 here to 91 days. And remember, this is being borrowed. I'm borrowing this one from the estimate, and we call it as the statistical estimation. In the estimation, we normally have a range. The range is, we normally say in basic statistics, we can say that maybe it is a population mean equals to sample mean plus or minus z, and we have the standard error. So now you see, when you talk of search, is what I've just done. That what I'm looking for, I'm just taking an estimate. Like now, this is our estimate. 85 is our estimate. Then plus or minus means if I do minus, I'm going to get the lower limit. If I use the positive, I'm going to get the upper limit. Then z is the 1.96. The standard error is what you have found to be 2.91. So that is actually how you get your upper and lower limits. And we can say, to balance it symmetrically, that this and this side are equal, the probability had to be divided by 2 as in the confidence level. And that is how we are able to get our lower and upper limit. Assuming that you did not have the idea of determining the standard error, and you thought that the standard deviation is going to be your answer. You know, sometimes you may find students or either somebody not using the standard error, and maybe you have used the standard deviation, which in this case is not going to be applicable that much, because you see we have used only five activities to represent the whole project. So that means it's a sample. So if, assuming that it was all the 8 activities, A, B, up to H, were critical activities, then we would have not taken the standard error. We would have taken the standard deviation to be our standard error. Yes, assume that would have been the case, that all the activities are the critical activities. Then, of course, we would have here as 1.96 times 6.51. Look at that. It would have been 85, the lower limit, minus 1.96 times the 6.51. This would be actually 72. 72 with 79. This would be 72. And the other one would have been 85 plus 1.96 times 6.51. This would have been 98. So 72, 98. The range would have been so great. The range would have been so great because of using the standard deviation instead of using what? The standard error. The standard error now is determined this way, and we end up having an error of 2.91, and it's the one we are going to use here. And when you do that, now we are having a range which is controlled. We are having 79 to 91. And that's now what we call the 95% confidence interval. Remember, the interval here depends with the percentage. If it was a 99%, 99% would have given us a 2.58. 99% would give you a 2.58 as the Z critical value. So therefore, the range would have been greater. A 90% confidence level would have given us 1.65. 1.65 is what we would have used here, and therefore the range become narrow. We normally say that the higher the confidence level, the greater the confidence interval, and vice versa.